Welcome back. This is module 9 in our programming basics playlist. Way back in module 1, we briefly saw how source code becomes an executable program. In this video, we are going to slow down and really dig into that entire journey: compilation, linking, loading, and finally execution, and what's actually happening in memory while your program runs. By the end of this video, you will understand exactly what's happening behind the scenes every single time you run a program. We will start by comparing source code, object code, and executables, then walk through compilation, linking, and loading individually. After that, we will look at how the CPU actually executes instructions, explore the stack and heap, compare static and dynamic memory, and finish by tying the entire journey together in one complete picture. Let's start by clearly separating three terms that are easy to mix up. Source code is the human readable code we actually write in our .c or .py files depending upon the programming language. Object code is machine code generated for just one file, not yet runnable on its own, typically a .o file. And an executable is the final complete program that operating system can run directly, our .exe file. So object code is like a puzzle piece. It's correct but incomplete on its own. It still needs to be combined with other pieces to actually form a runnable program. That combining processes exactly what we are covering next. Compilation. Compilation is the process of translating human readable source code into object code. The object code means machine instructions for that one file. So I have given a flow here. Main.c goes into the compiler and out comes main.o, the object code for that file. So the important details here is that each source file is compiled separately into its own object file, and the compiler also checks for syntax and certain type errors along the way, exactly what we covered back in module 7 when we talked about compilation errors. Then what is linking? Linking is the process of combining multiple object files and any libraries that they depend on into a single complete executable. In the diagram we can see main.o, utils.o, and a library called libmath all flowing into the linker, and out the other end comes a single complete executable program.exe. So the linker is actually doing behind the scenes. It resolves references between files. For example, if a function is called in main.o but actually defined in utils.o, the linker is what connects those two pieces together correctly. And once we have our executable, the next step is loading. Loading is the process of copying an executable file from disk into memory or RAM, so the CPU can actually begin running it. The flow is the executable sitting on disk gets picked up by the loader and becomes a running process in RAM. The operating system's loader sets up memory space for the program, including areas for code, data, stack, and heap. And once loading finishes, the program officially becomes what's called a running process. Now that our program is loaded into memory, let's talk about how it actually runs. Program execution. Program execution is the CPU actually carrying out the loaded instructions one at a time through a repeating cycle. That cycle has three stages: fetch, decode, and execute, FDE. And then it loops right back to fetch again over and over. Let's break each one down. Fetch means getting the next instruction from memory. Decode means figuring out what that instruction actually means. And execute means actually performing the action. This cycle repeats extremely fast, millions or billions of times per second for every single instructions in your program. So while a program is running, it actually uses two distinct regions of memory, the stack and the heap. The stack handles function calls, local variables, and return addresses. The heap handles dynamically allocated memory, memory that's requested and managed while the program is actually running. The stack grows and shrinks automatically in strict order as functions are called and finished. The heap is more flexible, but the programmer is more responsible for managing it themselves, which is exactly why heap related bugs tend to be trickier than stack related ones. And we have static memory and dynamic memory in programming concept as well, typically in the system. So static memory is allocated at compile time with a fixed size set in advance. It usually lives on the stack and it's faster since it's automatically freed when it's no longer needed. And dynamic memory is allocated at runtime with a flexible size decided while the program is actually running. It usually lives on the heap and it's slower because it must be freed manually by the programmer. A fixed size list of 5 numbers known in advance uses static memory, but a list that grows as the user adds items uses dynamic memory since its final size can't be known ahead of time. So now let's bring absolutely everything from this video together into one complete picture. Full journey. The source code goes into the compiler, becoming object code. That goes into the linker, becoming an executable. The executable is handed to the loader, which places it in memory using both the stack and heap. From there, the CPU takes over, running its fetch, decode, execute cycle, and finally, all of that produces our program's output. So compile, then link, then load, then execute, then output. Every single time you run any compiled program, all of this happens behind the scenes, usually in a fraction of a second. Let's recap everything we covered in this module. Source code becomes object code through compilation, and then object code and libraries combine into an executable through linking. Loading copies that executable into memory, where it officially becomes a running process. The CPU executes instructions through a repeating fetch, decode, execute cycle. And the stack handles function calls and local variables, while the heap handles dynamically allocated memory. So that wraps up our module 9. Understanding this whole journey gives you a much deeper appreciation for what's actually happening every time you hit run on your code. If this behind the scenes look help things click for you, drop a like and I will see you in the next video. Thank you.